This video provides an overview of our approach to modernizing retail integrations in response to changes in the Oracle ecosystem. We'll outline the migration challenges organizations are facing, introduce a practical solution architecture, and demonstrate how it supports reliability, scalability, and long-term operational control. The goal is to show how retailers can move forward with confidence while preserving the governance they depend on. To begin, let's look at the broader context behind this project. Retail integration is going through a significant transition as legacy Oracle platforms are phased out. For many organizations, this isn't just a technical upgrade, it's a strategic shift that affects how systems communicate and how operations are governed. In this presentation, we'll walk through how that shift can be handled in a controlled and future-focused way. Naturally, this transition raises important questions for retail leaders. The biggest concern is exposure, whether discontinuing previous platforms could introduce operational risk. Integration sits at the core of daily business processes, so reliability is critical. The move toward cloud technologies from Oracle Corporation creates an opportunity to modernize, but it must be done without sacrificing stability. This leads directly to the central challenge of migration. While Oracle Integration Cloud provides a powerful cloud-native environment, it doesn't automatically replace the operational governance retailers relied on in earlier systems. The real task is bridging that gap, combining modernization with the same level of monitoring, control, and resilience teams expect in production. To address this gap, Quickborn Consulting Services developed a solution specifically focused on safe migration. The idea is not just to move integrations into the cloud, but to restore enterprise-grade governance around them. This ensures that as organizations transition, they maintain visibility, auditability, and operational confidence. Before diving into the solution itself, it helps to briefly consider the legacy integration landscape. Traditional architectures were built around centralized governance and tightly controlled message handling. Understanding this baseline makes it clearer what needs to be preserved as we move toward a cloud-based model. With that context in mind, our solution introduces a modern integration framework that retains the strengths of the previous model while improving scalability. It combines advanced retry mechanisms, batching and throttling capabilities, and automated testing. Together, these components form a resilient backbone designed for enterprise retail workloads. A key part of this framework is the hospital and retry mechanism. Instead of allowing failures to disrupt operations, messages are captured, tracked, and retried in a controlled way. This systematic handling of exceptions protects business continuity and reduces the risk of unnoticed errors. To support scalability, the system includes configurable batching and throttling capabilities. Messages can be grouped and processed in batches, optimizing throughput and reducing processing overhead. Throttling ensures that system resources are not overloaded, maintaining stable performance even during peak volumes. Together, these features allow the integration framework to handle high message loads efficiently while preserving operational control and reliability. Closely related to this is dependency management. Retail integrations often involve sequences of related messages that must be processed in order. By actively managing these dependencies, the system preserves data consistency and prevents cascading issues across connected services. Operational visibility is equally important. Centralized configuration, monitoring, and logging give teams a clear view of system behavior. This transparency allows faster troubleshooting and more proactive system management as integration volumes grow. Another core pillar of the solution is the automated testing framework. Integration changes can introduce subtle issues that are difficult to detect without systematic validation. This framework enables large-scale automated regression and stress testing, allowing teams to continuously verify integration behavior as the system evolves. By embedding testing directly into the architecture, organizations gain higher confidence and stability while reducing manual effort and risk. On these operational foundations, the architecture transitions into an OIC-based landscape optimized for cloud deployment. Pre-built mappings connect legacy message structures with modern APIs, reducing implementation effort and speeding up adoption. Within this environment, packaged integrations handle message forwarding, dependencies, and hospital logic out of the box. An Apex-based control interface provides administrators with a centralized operational dashboard that can be deployed flexibly across cloud environments. To ensure reliability during and after migration, the solution includes an automated testing framework. It generates dynamic test scenarios, executes them at scale, and supports continuous validation of integration flows. Equally important is how results are captured. Integrated reporting tools provide visibility into test execution, enabling teams to track performance and make informed adjustments throughout the life cycle of the system. Here's a closer look at the user interface in action. It's intuitive, configurable, and presents all necessary tools on a single screen. You can maintain, review, and edit messages directly, while the system manages dependencies and retries automatically. The interface allows you to select a message, make edits, and trigger a retry in just a few clicks, with all related messages tracked in context. Centralized configuration, monitoring, and logging provide full operational visibility, supporting efficient management and troubleshooting of message flows. This approach maintains business continuity while accelerating modernization. It avoids costly redevelopment and provides a structured path toward cloud integration. Beyond immediate migration benefits, the architecture supports long-term scalability. It establishes a future-proof integration strategy that can evolve alongside business needs and emerging cloud capabilities. An important outcome of this design is reduced operational risk. Built-in safeguards ensure that integration reliability remains a priority, both during migration and in ongoing operations. At the same time, the framework is designed to be efficient and manageable. It delivers strong operational value while keeping implementation and maintenance costs under control. A recent case study highlights the practical impact of this approach. Pilot integrations were completed within 3 months, and during peak trading periods, the system handled over 1 million messages daily. At the same time, operational costs were significantly reduced compared to the previous platform. This concludes the overview of the retail integration migration journey. The approach combines modernization with operational reliability and creates a scalable foundation for future growth. We welcome further discussion with organizations planning their transition.